Okay, welcome back to part 2 of implicit differentiation, where we rage against my dying battery and see if we can beat it to the finish. Okay, so here's we're going to look at some more examples of problems dealing with implicit differentiation. So here's the situation, right? We saw this before. Find all the points on x squared plus y squared equals 25 with horizontal and vertical tangents. So first off, before we do any problems, let's talk about what that means. So if you have a horizontal tangent, what does that mean? Well, that means you have a slope of 0, right? It's flat like that. If you have a vertical tangent, vertical of course means straight up and down, so that would be the point on the curve where you have a vertical line. Well, what's the slope of a vertical line? That slope is undefined. Okay, and typically when we're undefined, we're something divided by 0. So here's how we're going to solve these problems. The first thing, of course, is to find dy dx. Well, we actually did this problem earlier, so it's 2x plus 2y dy dx equals 0. So your dy dx is equal to negative x over y. All right, so if you need horizontal tangents, again, a horizontal tangent is when my dy dx equals 0. So negative x over y equals 0. When a fraction equals 0, that means that the top must equal 0. It's got to be 0 over something. So negative x equals 0, so x equals 0. But the problem asks me for points. So if I need to find points, I need to do what I did at the end of the previous video, and I need to plug back in to the original. The original gives us the points on the curve, not the slope, the original. So I got to go all the way up here and plug in this equation here. So we plug in x equals 0. So we get 0 plus y squared equals 25. So y equals plus or minus 5. So the points are 0, 5 and 0, negative 5. Okay, and this should actually make sense, right? Because this graph, this x squared plus y squared equals 25, is a circle. And a circle, if it's centered at the origin, at the top and the bottom has horizontal tangents. Great. Okay, now when we do a vertical tangent, we're going to do much the same thing. So we're going to do a vertical tangent. I'm going to, again, set the dy dx to equal something divided by 0. So I'm setting the denominator of your slope to equal 0. All right, so your dy dx in this case is equal to negative x over y. So in this case, that y equals 0. Great. So now, again, I plug in the original to get the point. The original was x squared plus y squared is 25, so x squared plus 0 equals 25. So x equals plus or minus 5. So we have 5, 0, and negative 5, 0. Okay, so what that means then is, again, this makes sense, right? 5, 0, negative 5, 0. The sides of the circle do, in fact, have vertical tangent lines. Great. So let's take a look at one or two other ones like this. So when you have, for example, y to the 4 plus 4y equals x minus 3, and I ask you to find all points with a vertical tangent. So again, feel free to pause this video and try this out on your own, see if you get the same answer. Well, a vertical tangent, again, is when your dy dx is undefined, something over 0. Don't memorize that, just kind of remember, oh, a vertical line, yeah, it's an undefined slope. Cool. So that means we'll take a derivative, so 4y cubed times derivative of y plus 4 times derivative of y equals 1. So my dy dx, factor out 4y cubed plus 4 equals 1. So my derivative here will be 1 over 4y cubed plus 4. So once I found my dy dx first, now I set the denominator equal to 0. So I set 4y cubed plus 4 equals 0. All right, so we'll solve that. So we'll get y cubed equals negative 1. So y is the cube root of negative 1, which is negative 1. Okay, now again, to find x, because the problem asks for points. Whenever a problem asks for points, it needs an x and a y. To find x, I need to plug this in the original. So take this negative 1, plug it back in up here. We've got to plug it in for both the y's. And this will give an equation, right? Negative 1 to the 4 is 1 minus 4 equals x minus 3. Oh, that worked out nicely. So we get 0 equals x, right? So that means that the point is 0, negative 1. Okay, so that's how you solve these problems that have a vertical tangent or horizontal tangent. You see is where is that slope undefined for vertical or a slope of 0 for horizontal. Okay, so let's talk about one more thing that's very exciting, which is the second derivative. Okay, And the second derivative, which we usually write as d squared y dx squared, I want to go back just to kind of a basic case. So for example, say we don't have an implicit differentiation. Say you had f of x equals 4x cubed plus e to the 2x, and I ask you to find f double prime. Well, you guys know how to do this, right? F prime is 12x squared plus 2e to the 2x. So then when we take our second derivative, that is the derivative of f prime. So the derivative here is 24x plus 4e to the 2x, right? Just the derivative of the first derivative. And we're actually going to do the same thing here. So when I have, let's go back to the example from the beginning of the video, x squared plus y squared is 25, and I ask you to find that second derivative in terms of x and y. Well, your first step, of course, should be to find the first derivative. So your first step is find the first derivative of dy dx. I've already done that, so I'll just skip the steps. dy dx is negative x over y. Now, when you want to find the second derivative, now we're going to take the derivative again. So we're going to take the derivative of dy dx. And again, we have to take the derivative of both sides. And again, we're going to have to use the chain rule on y, and that's going to give us more dy dx's. Okay, so when I take the derivative of dy dx, that gives me the second derivative. When I take the derivative of negative x over y, I'm going to have to go ahead and use the quotient rule. So I'm going to have low d high, derivative of negative x and negative 1, minus high d low. Square the bottom, away we go. Now, you might be we're rocking in the free world, but one of the things about this problem is it told us to do it in terms of x and y. So to do it in terms of y, what we need to do is we need to plug in for dy dx. Which again, the great thing is, we found dy dx. That was the first thing we need to do. So when we found our second derivative, the first derivative already appeared. So we need to take that dy dx and just plug it in. So when I plug it in, I'm going to get negative y plus x times negative x over y squared. Okay. Now, is this a little ugly? Sure. But that's what we need to do. We need to find the first derivative, then take the second derivative of that, and then plug in. Let's do one more. For example, if we have y, if you feel good about that one, you can move on. But this one's going to be a little nastier, so you might want to take a gander. That is a horrible y. So we have y cubed minus 3y equals the sine of x plus 1. And I'm going to ask you to find dy dx and d squared y dx squared in terms of x and y. Okay, so let's go ahead and take the derivative of both sides. So the derivative of y cubed is 3y squared times the derivative of y. The derivative of y, of course, is just dy dx. Derivative of sine x is cosine x. So I'll just factor this out quickly. So dy dx times 3y squared minus 3 equals cosine x. So that means that my dy dx will be cosine of x over 3y squared minus 3. That's my first derivative. So we're halfway done. Now, to find the second derivative, I just differentiate this. Oh, we're going to make it. So the derivative of the first derivative is d squared y dx squared. And I'm always going to need to do, almost always, some kind of quotient rule or product rule. Definitely the quotient rule here. So let's set this up. So we have a low d high. Derivative of cosine, of course, is negative sine of x. Minus high d low. Derivative of 3y squared is 6y to the first times dy dx. And the derivative of 3 is 0. And square the bottom, away we go. Okay, now the last step, of course, is just plugging in, give me a good color, is just plugging in for the dy dx. So let's go ahead and plug that in. So we found that again right here. So we just plug this in to my second derivative. So we're going to get 3y squared minus 3 times negative sine x minus cosine x times 6y times, and we have a fraction of fraction, which of course is disgusting. And we will divide this whole thing by 3y squared minus 3 squared. Now, you're definitely not going to simplify this, and I know this is hideous, but that's the idea. So yeah, second derivative is take the derivative of the derivative and plug in the dy dx. Okay, 5%, we made it. Thanks for watching. Bring questions to class. I'll see you soon.